So welcome to Electronics Ishalaya, and you are watching the digital electronics lecture series. Today is the topic of discussion in the number system conversions. Okay. So in the previous class we have seen what is the number system, then what is the base or radix of the number systems. So in this lecture we will see how any number system that can be converted into the digital number system. So we are talking about the positional number systems. Okay. And then we will see any decimal means any uh, means this decimal system will how it can be converted into the any base number system. Then we'll see the octal to binary number system. Okay, and then we'll see the hexadecimal to binary number system, and vice versa. We can have binary to hexadecimal also. Then we can have binary to octal also. Okay, so let us start our discussion. The first one is your any base to decimal number system. Okay, so any positional number system, how it can be converted into decimal number system. So the method is that, so you have to identify the actually the positional weights. Okay, so of that number system. Then you have to multiply the digit with the weights. Then add all the products. So this is the conversion method. If we are doing the conversion from any positional number system to decimal number system. Okay. So next one is this is for example this one. Okay. So this is a binary number system. We need to find out the what is the equivalent decimal number system. It is how it is converted into decimal number system. Okay. So first you have to identify the positional weights. Okay. In this case the actually base is here 2. Okay. So each digit is some having some weights. Okay. So let us see that. You have to multiply that. Okay. So you can see over here. So this is the uh, this is the weight is here 2 to the power of minus 1. This weight is here 2 to the power minus 2. Okay, and this weight is here 2 to the power minus 3. Likewise, okay. So this is here 2 to the power 0. Okay, then this weight is here 2 to the power 1, 2 to the power 2. Okay, so last one is here 2 to the power 4. So you have to multiply this all with the digits. Okay, so you can see 1 that will be multiplied with the weights. So weight is here, these are nothing but the place values. Okay. So 1 into 2 to the power 4. Then 1 into this is the weight is 2 to the power 3. This digit has the weight is 2 to the power 3. Similarly, this digit has the weight is 2 to the power of 2. So likewise, you can see this after the fractional part that this weight is 2 to the power minus 1. So it will be 2 to the minus 1, then 2 to the minus 2, then 2 to the power of minus 3. Okay. That will be multiplied with each digit. Okay. Then you have to add the products. Okay. So likewise. Okay. So you have to likewise add the products. So this is the answer 26.375. So we have converted the in this case we have converted the binary number system to decimal number system. Okay, likewise octal to decimal number system. Okay, so octal is the base is 8. So you can see you have to multiply with the some positional weights. Okay, so 7 into that will be 8 to the power of 2. This is the this weight is your here is your 8 to the power 0. This number is the or this digit has the weight is 8 to the power 1. This digit has the a weight is 8 to the power 2. This digit has the weight is 8 minus 1. This digit has the weight is 8 minus 2. So you have to multiply this. Okay, to the each digit. This is the digit. This is that place value or weights. Okay. So now it will be our decimal number system. So this is our decimal number system. So we have converted the octal to decimal number systems. Okay. Similarly, this one we can convert. So 23 means 2 into that is 8 plus 3 into 8 to the power of 0. Okay. Likewise, 8 to the power minus 1, 8 to the power minus 2 and minus 3. Okay. So this is the means we have this express this digit in means number into the sum of the digits. Okay, so the answer is this one. So this is the octal to decimal number system. Okay. So octal uses the power of 8. Okay, the octal number system that uses the power. This is base is 8, so it uses the power of 8. The fractional position use the negative power, that is 8 to minus 1. After the fraction, it will be 8 to the power minus 1, minus 2, minus 3, likewise. Okay. So this is how you convert from octal to decimal. Okay. So every octal digit must be in the range of 0 to 7. Okay. Similarly, hexadecimal to decimal. Okay. So in this case, the hex digits are we can have A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay. So ABC point. So this is a decimal number system. You have to convert it into the this is the hexadecimal number system. You have to convert it into the decimal number system. Okay. So here this is A means it is 10. So 10 into this is the weights of that A. This is 16 to the power 2, like 11 to the power 16 to the power 1 plus 12. There is 12 means C. Okay. 10 is 16 to the power 0. Likewise. Okay. So you multiply and sum it out. This is our decimal number system. That is how we convert from hexadecimal to decimal. Likewise, this one also. So what is the weights? This weight is your 16 to the power of 2. Okay. This is the weight is 16 to the power 1. Likewise, this is 16 to the 0. Okay. That is minus 1. 16 to the minus 1. Likewise. Okay. So just multiply. So it will be 7 into 16 to the power 2, then 6 into 10 to the power 1, then likewise. Okay. So just multiply it and let's sum it out. This is our decimal number systems. Okay. So why hexadecimal is convenient? Because the large binary values that is can be using in the symbols. We can use the symbols. Okay. So this is our hexadecimal to decimal number systems. Next is your decimal to any number system. So first we will see how to convert decimal to binary. Okay. So there are two things. There one is the integer part and one is another one is fractional part. For the integer part, we can use the successive division by 2. Okay, because it is decimal to binary, that is why successive division by 2. Then collect the remainder from bottom to top. So you have to collect from bottom to top. Similarly, fractional part. For the fractional part, we can use the successive multiplication by 2. Since it is a binary number system, we are converting. Then collect integer parts from top to bottom. Then combine all the integer and fractional part. This is the method. Okay. For any decimal to any number system, we have the method. Only the this value will be changed. That is the base. Okay. So this is the decimal number system. We need to convert it into the binary. So 1818 is your means integer part. Point means after the point it is a fractional part. So for integer part, what we have to do? Divide by 2. Okay. For integer part, you can divide by 2. Likewise. So 18 divided by 2. That will be quotient is 9. So 0. Then the quotient is 9. So 9 divided by 2. So we can have you can have right in this way also. So 18 divided by 2. The remainder is 9. So the remainder is 0. Similarly 2, 4. The remainder is 1. Okay. So 2, 2. The remainder is 0. Likewise. 2, 1. The remainder is 0. So you can collect this value from bottom to top. Okay. So bottom to top means this way. Okay. Bottom to top. Okay. So it will be 1. It will be 1, 0, 0, 1, 0. So 1, 0, 0, 1, 0. So you can have bottom to top likewise. Okay. So bottom to top. Okay. So this is for the fractional part. What we need to do is the for fractional part you need to the multiply. Okay. So you need to the multiply the fractional part. Okay. And we'll take that from top to bottom. Okay. So you can also multiply like in this way also 0.625 into 2. So that will be 1.25 I think 250 into 2. So this will be 0.5. Okay. 500 into 2. So that will be 1.00. So it have the 00. So you don't need to multiply that. Okay. So it will we can collect from actually uh, top to bottom. Okay. So here you can collect from top to bottom. Okay. Okay. So this is the way. So 101. You don't need to multiply this because we are getting this only. Okay. So this is the result. So that will be 100. This is the means integer part. This is the fractional part. We can have this only. Okay. We can have 101. Okay. So likewise, you can have decimal number system to binary number system. Okay. Next is your decimal to octal number system. So in this case also you have to successive division by 8. Okay. The fractional part you have to multiply by 8. Okay. So this is our octal number system. You need to find this is our decimal number system. You need to find out the octal number system. So 172 divided by 8. So these are the reminders. Okay. These are the reminders. So it is 254 or 254. Okay. That is the integer part. Similarly, you need to find out what is the means fractional part. So you just multiply. Okay. So multiply then we can take here is your top to bottom. Okay, so top to bottom means it is 0.7015. Then combine the integer part and fractional part. So that will be 254.7014. This is in the octal. Okay, so we have converted the decimal number system to octal number system. So last one is the decimal to hexadecimal conversion. So similarly, for integer part, the successive division by 16. For fractional part, we have to successive multiplied by 16. Okay. So this is the number. So first you have to divide by 16. Okay. So this is the we will get this reminders are there. Okay. So you can take over here. So it will be you can have means bottom to top. So it will be 312. Okay. Similarly, for fractional part, you have to multiply here. So you can take here. This is the means reminder. You can take this 15, that is F. Okay. Then 11, that is the 11 is your B. Then 10, it is written as A. Likewise. Then 5, we have the 5. Okay. So this is the you can take over here the means top to bottom. Okay. So in this case, we can take here top to bottom. Okay. Just multiply this. Okay. And you have to combine that. Okay, so the final result is this one. Okay, the final result is this one. So we have converted the decimal number system to hexadecimal number systems. Okay. Next one is this is the conversion workflow that we have done so far. So identify the base first, then integer to a decimal number system. What we are doing? Digit into this is the base. R is the base into that means position, that position values. Okay, that we have to multiply. Okay. So this is integer to decimal, then decimal to integer. What we are doing there? We are dividing by target base. Okay, for the integer part. For the fractional part, what we are doing? We are multiplying by target base. Okay. So for integer conversion, read the reminders from the bottom to top. For fractional conversion, read the generated integer from top to bottom. Okay. So next one is your octal to binary or binary to octal. So what we can do? This is the octal number system. You need to find out the binary number system. So just you can binary equivalent. Okay. Binary equivalent. What is the binary equivalent of 7? It is 111. Similarly, what is the binary equivalent of 3? It is 011. So likewise 110. So you have to find out the binary equivalent of this 7, 3, and 6. Okay. In terms of 3 digits. Okay, you need to find form in terms of 3 digits. Okay. So then combine. Then it will be 10111. This 11147. Okay, this one for 7. This 3. This 01143. Then this 110 for 6. Okay. Similarly, this is the actually number. You need to find out the means this is the binary number. You need to find out in the decimal numbers. This octal, sorry, this is octal number system. Okay, so it is actually from what we are doing. Actually, you can see over here, the octal numbers are converted into equivalent binary numbers by replacing each octal digit. Okay, so we are doing replacing each octal digit by 3-bit binary equivalent binary starting from the LSB. Okay, and moving towards the MSB for the integer part. Okay, so we are taking the 3-bit equivalent binary. Okay, from the LSB and then moving towards the MSB part. Similarly, for fractional part, what we are doing, the procedure repeated. This is the fractional part. The starting from the bit next to the binary point and moving towards the right. Okay. So you can see over here. So for fractional part, you can take 0 means you can see this 3 you can take. Okay. This 3, then this 3, then this 3. So this is the 1. This is your 7. This is your 5. And this is your 0. That is what is written in 0571. Okay. So for the integer part, you can see this 3. Okay, starting from the LSB. Okay, so this is the LSB of that integer part. Then you can take this one. Okay, and then this 3 you can take. So this is your 1. This is your 6. This is your 1, and this is your 3. Okay, so likewise you can get the octal number. So it is the octal to binary and binary to octal. Okay. So the last case is your similarly, the last case is your hexadecimal to binary and binary to hexadecimal. So this is the number which is in the hexadecimal. Sorry, this is the hexadecimal. So you need to write here 16. Okay. So you need to find out the binary. So both of binary equivalent you can say You can take the binary equivalent of A, then 7, then 2, then E. Okay, this is for the binary equivalent of A. You can take over the 4 bit. Here we can take the 4 bit. In the previous case, we are taking the 3 bit. In this case, the difference is that we are taking here the 4 bits. Okay, so this is the equivalent E. This is that for 2. This is for 7. This is for A. Okay, then combine all this. Okay, so this is our result. Okay, so this is hexadecimal to binary. Okay, similarly binary to hexadecimal the same concept. Okay, so for hexadecimal and hexadecimal to binary, so we have what we have done is that you can take, so replace the hexadecimal digit by 4 bit equivalent binary starting from the LSB and moving towards the MSB for integer part. Okay, similarly for fractional part, the procedure repeated for the bit next to the binary point. Okay, and moving towards the right. So in this case also we can see for fractional part, there is the bit next to the binary point. Okay, so you can take the 4 numbers 1, 2, 3, 4. So you can append 0 if there is no means extra 1 or 0 is there. You can append. Okay, so this is 1, this is your 7, this is your 9. So 179. And in this case, we can take from this side, LSB side. This is your 4. You can take this 4. Okay, and this is the 4. So this is 1. This is 7. This is just 6. So this is 671.178. Okay. This is how you can convert from this is base 16. Okay. So this is how you can convert from hexadecimal binary and binary to hexadecimal. Okay. So let us sum it up. Actually, we have checked that binary number system. We know binary number system uses only 2 digits, octal 0 to 7, hexadecimal that is the 0 to 9, then A to F. Decimal we have 0 to 9. Okay. Then check the radix point, the integer position use non-negative powers. Okay, the fractional uses the negative powers. 10 to the minus 1, that is why I am writing 10 to the minus 2 or 2 to the minus 1. This is the fractional position that uses the negative pair. The integer is 10 to the power 2. These are the non-negative powers. Okay. Similarly, check the hexa symbol, that is A to F, represents the decimal value, that is 10 to 15. Okay. For check 4, there is the integer conversion. Successive division is applied, and you can take the remainders from bottom to top. Okay. For integer conversion, for fractional conversion, we are doing the successive multiplication. We are taking the integer parts from top to bottom. Okay. Next one is you can verify that. Okay. So let us sum it up. So we have done, we have checked what is the base of the number system. Then we have used the positional weights and the sum the product. This is the base, any base number system to decimal. Okay. Then decimal to any base, we have done. We have divided the for the integer part, and for the fractional part we have multiplied. Similarly, octal to binary, we are replacing each digit by octal digit by the 3-bit equivalent binary. Similarly, hexadecimal to binary, what we have done, we are replacing each hex digit, that is hexadecimal digit, by its 4-bit equivalent binary. Okay. So we have some practice question you need to do. Okay. So that's all in this lecture. So we have discussed about the number system conversions. Okay. So if you have any doubt, you can free to ask me in the comment section. Okay. So thank you all. Have a nice day.